Hello, YouTube. This is Mr. Bakari, and today we are going to multiply and divide complex numbers. Now, specifically, we are going to work with the trig form of complex numbers, and we're going to use these rules to get it done. So let's get started. So let's look at complex numbers. Up top, we've got some in rectangular form, and you probably have previously multiplied and divided them as is. So what does that consist of? Well, it's a bit of work. Okay, you're going to have to FOIL, you're going to have to multiply by conjugates, you're going to have to simplify I squareds, combine like terms, all that kind of stuff. Well, what this allows us to do is write them in trig form, and we can get it done in a matter of seconds. So we're not going to multiply it that way, and we're not going to divide it that way. We're going to look at them in trig form. So what our rules state is the first one says if you've got two complex numbers and you want to multiply together, you can multiply their R values and then write CIS, which stands for cosine theta plus I sine theta, and then add their angles. And that's it, you're done. Okay? And if you want to divide two complex numbers in trig form, you would just simply divide their R values, write CIS, and then subtract their angles. Okay? So it makes this process very simple. And so we're going to do a couple examples of each. So first up here, we've got two complex numbers on the left. We're going to multiply them together, and then we have an example here on the right. Now, the ones on the left, okay, they need to be in trig form, obviously, first to apply these rules. And what we're going to do is we're going to take their R values, 5 and 3, and we're going to multiply them together. And that will give us 15 and then bring down CIS. Now, in this video, we are going to write the shorthand of this. This just means, again, cosine theta plus I sine theta. And then we're going to add our angles together. Okay? So we'll get a common denominator here, which would be 24. And that's going to be 3 pi over 24 and 16 pi over 24. Add them together, and we have 19 pi over 24, and that is it. There's our product. It's that simple. Okay? Let's look at the second one. All right, here we're going to take our R values 4 and negative 2 and multiply them together. Carry down CIS, and then we are going to add the angles. Okay? So here we'll get a common denominator of 12, and that'll be 9 pi over 12 plus 2 pi over 12. Add that together, 11 pi over 12, and there is our product. And the way you say that is, in this shorthand, is negative 8 cis 11 pi over 12. Okay? All right, so let's look at division. Division, again, make sure that both of your numbers are in trig form. And what we do here is we simply just divide our R values. So we're going to take 10 divided by 2, which is 5, bring down cis, and then this time we are going to subtract our angles. So let's get a common denominator here. That'd be 12. So I have 15 pi over 12, and I have, let's see, 4, 8 pi over 12. And so that's going to give us 7 pi over 12. That's the difference. And here is our quotient. All right. And the last one, same thing. 6 divided by 2 is 3. Bring down cis. And then pi over 2 from pi is just simply pi over 2. Now down here it says, what about writing your answer in standard form? So sometimes you're asked to write your answer in standard form. Perhaps the question was in standard form and you changed it to trig form in order to use these rules. So let's go ahead and do that. So in order to do that, we're going to expand this, okay? So we're going to carry out 3, and And we're going to multiply 3 by c, which stands for cosine theta, which is cosine pi over 2, plus I sine pi over 2. Okay? And then all we have to do to put this in standard form is to distribute the 3. Okay? So in order to do that, we want to evaluate cosine at pi over 2. So cosine at pi over 2 is just 0. And sine at pi over 2 is 1. Okay? So now if we distribute 3, 3 times 0 is 0, and 3 times 1i is 3i. So this is just the imaginary number 3i. Okay, and there's the standard form of your quotient. All right. So just a quick video. Wanted to show you this really quickly and show you how easy and useful this can be. I hope this helps you out, and I'll see you in the next video.